This is a short video about thermal chemistry, specifically about specific heat, and more specifically about how you can use the specific heat of different substances to determine other properties of other substances. Let's start off with an example of some object that's, we'll say, hot. So I got object A. So if I would like to know something about object A, say object A's specific heat, then I could calculate that by using the equation Q equals mc delta T. So I'd need to know the object's mass, I'd need to know how much heat the object absorbed or gave up, and I'd need to know what would happen to the change in the temperature. Did the temp go up? Did the temp go down? And from that, then I can calculate out my specific heat of that particular object. The hard part usually is it's a little difficult to calculate this portion out. But if I use another substance, say water, then I can actually determine the amount of Q that this, in this case, this hot object A gave up. So we've got another object. In this case, the object is going to be water. So I've got some water here. I'm going to plunge object A into the water. If object A is hotter than the water, then A is going to increase the water's temperature by releasing energy into it. And that energy is this Q. So if I can calculate how much energy the water gained, then I can calculate how much energy that object A lost. So let's do this example. I've got object A, and I know object A's mass is, say, and it doesn't really matter, 250 grams. Great. So object A's mass is 250 grams. And I know object A's temperature, initial temperature, because I was heating it in an oven, and its initial temperature was, say, 450 degrees Celsius. I will eventually know its final temperature because I'll be able to figure out what the water's final temperature simply by dropping a thermometer in there. Alrighty, so let's say that this water that I've got, that the water's mass is, 2,500 grams. And that the water's initial temperature is somewhere around room temperature, so we'll just say it's 20.0 degrees Celsius. The object goes in, it heats up the water. It stops heating the water, and the water's final temperature is, say, 22 degrees Celsius. So great, we raised the water temperature by 2 degrees. Where did the energy come to raise the water's temperature by 2 degrees? It had to come from this object A. So I also learned something else, because the reason that the water temp stopped going up is because the water and object A finally reached the same temperature. So then that means I know the temperature final of object A is also 22 degrees Celsius. So obviously the water temp went up and object A's temp went down considerably. Okay, so if I want to figure out what this Q value is, I could figure out what it is based off of the water. So how I'm going to use that is the mass of the water is, I'll put this in blue since we're talking about the water. The mass of the water is 2,500 grams. And the specific heat of the water is 1 calorie per gram degree C. And the change in temperature of the water is final temperature minus initial temperature, so just 2 degrees Celsius. And this is going to be the Q of the water. So if I do this calculation, it's 5,000 calories. 5,000 calories. The math works out for us using this railroad track because the degree C cancels out with that degree C and the grams cancels out with that grams. The only unit I've got left is calories, and I accidentally did a mistake there, so that's why we're doing this. That's why you always manage your units. So this was supposed to say calories because I was calculating Q. All right, so what I know is this is the heat that the water gained. What I also know is all of that heat came from object A. So object A, I want to change that. Let's go back over to this green pen. Object A's heat loss during this is 5,000 calories. It lost it, obviously, because its temp went down and it gave it to the water. Okay, so now I know lots of information. What I mean by lots of information is I know enough information to calculate what I was looking for. So this information here is enough to complete this equation for allowing me to solve for C. So what is it I'm looking for? I'm looking for a specific heat. What are the units for specific heat? Specific heat's units have to be an energy unit divided by a mass unit and a temp unit. So in here, in this case, with all of these units that we have here, it would be good to have calories divided by grams and degree C. Do I have that up here? Sure. I have calories right here, the negative 5,000. I've got grams right here, and I've got these 2 degree C numbers that give me my change in temperature. Let's do that change in temp calculation right now. So the change in temperature of object A is 22 degrees Celsius minus 450 degrees Celsius. So then my change in temp for A is negative 428 degrees Celsius. Great. Okay, so I need to set up my calculation to give me these units up here. So what I'm going to do is I'm going to say negative 5,000 calories, and I'm going to go ahead and divide that by 250 grams because that's the mass of the object A, and then the change in temp is negative 428 degrees C, and I need a calculator. So 5,000, sorry, negative 5,000 divided by 250 divided by negative 425, and I get 0.046729 calories per gram degree C. So to finish this off, let's look for significant figures. So in this case, it looks like my significant figures are, I have 2 here and 2 here and 2 here, 2, 2, 2. So it looks like 2. I can write this to 2 significant figures. So then my answer for the specific heat of my object A is going to be 0.047 calories per gram degree C.